Welcome to my channel, Worldwise. Why are there not more people talking about Pluto, once considered the ninth planet from our sun? It has long fascinated astronomers. In 2006, it was reclassified as a dwarf planet. This decision sparked controversy. Pluto resides in the Kuiper Belt, a region beyond Neptune populated by icy bodies. Pluto's orbit is unusual. It's elliptical and tilted compared to the other planets. Sometimes Pluto's orbit even crosses inside Neptune's path. But don't worry, they won't collide. A fascinating cosmic dance keeps them apart. One of Pluto's most striking features is its heart-shaped region, known as Tombaugh Regio. The western lobe of this heart, called Sputnik Planitia, is especially intriguing. Scientists believe this smooth, icy plain was formed by a colossal impact billions of years ago. Imagine a planetary body hundreds of miles wide slamming into Pluto. This impact excavated a massive basin. The impactor's core likely sank, creating a dense mass beneath Sputnik Planitia. This mass excess explains the region's equatorial location. Previous theories suggested that Sputnik Planitia's location was due to a subsurface ocean. This ocean, it was thought, caused the region to reorient itself. However, recent studies using computer simulations challenge this idea. These simulations successfully recreated the formation of Sputnik Planitia without any subsurface ocean. The collision theory, with its impact-driven mass redistribution, provides a more compelling explanation. While the presence of a subsurface ocean on Pluto was once a popular hypothesis, it seems less likely now. Section 4. Dwarf planet or not? The Great Pluto Debate. In 2006, the International Astronomical Union, or IAU, redefined the term planet. This redefinition was a significant moment in the field of astronomy, as it changed the way we categorize celestial bodies in our solar system. The decision was not made lightly and involved extensive discussions and debates among astronomers from around the world. Pluto, not meeting all the criteria, was reclassified as a dwarf planet. This decision remains controversial. Many people, both in the scientific community and the general public, were surprised and even upset by this change. Pluto had been considered the ninth planet in our solar system since its discovery in 1930. Its reclassification sparked a lot of discussions and debates about what it means to be a planet. One key factor was Pluto's inability to clear its neighborhood. In other words, Pluto's orbit is populated with other objects, such as those found in the Kuiper Belt, a region of the solar system beyond Neptune filled with small icy bodies. This inability to clear its orbit was a crucial criterion in the IAU's definition of a planet. This means its orbit isn't free from other objects. Unlike the 8 planets which have cleared their orbits of other debris, Pluto shares its space with many other objects. This characteristic is one of the main reasons why Pluto was reclassified as a dwarf planet. However, some argue that Earth and Jupiter also share their orbital space with asteroids. These planets have not completely cleared their orbits either, yet they are still considered planets. This argument highlights the complexity and nuances involved in defining what constitutes a planet. The debate raises questions about what truly defines a planet. Is it size? Is it orbital dominance? Or perhaps a combination of various factors? The reclassification of Pluto has led to a broader discussion about the criteria used to define planets and whether these criteria should be reconsidered. Or is it something else entirely? As our understanding of the universe continues to evolve, so too might our definitions and classifications of the celestial bodies within it. The debate over Pluto's status as a planet or dwarf planet is a reminder of the ever-changing nature of science and our quest to understand the cosmos. Section 5. A Cosmic Dance. Pluto and Neptune's Orbital Resonance. Despite their seemingly chaotic orbits, Pluto and Neptune are locked in a gravitational waltz. This fascinating relationship is a result of their unique orbital resonance, a phenomenon that has intrigued astronomers for decades. The gravitational forces between these two distant worlds create a harmonious pattern that keeps them in sync, despite the vast distances separating them. They share a 3-to-2 orbital resonance. This means that for every 3 orbits Neptune completes around the Sun, Pluto completes exactly 2. This precise ratio is not a coincidence but a result of the gravitational interactions that have shaped their paths over millions of years. This means for every 3 orbits Neptune makes around the Sun, Pluto completes 2. This elegant dance ensures that the two bodies never collide, despite their orbits crossing paths. The resonance acts as a cosmic safeguard, maintaining a delicate balance that prevents any catastrophic encounters. This elegant dance ensures that the two bodies never collide. The gravitational pull between them creates a stable configuration, allowing them to coexist peacefully in the vast expanse of space. This relationship is a perfect example of how gravity can orchestrate complex movements and maintain order in the cosmos. Even though Pluto's orbit sometimes crosses inside Neptune's path, their resonant movements keep them safely apart. This intricate dance is a testament to the precision and beauty of celestial mechanics. The resonance ensures that their closest approaches are timed perfectly to avoid any potential collisions. This cosmic choreography is a testament to the intricate workings of gravity in our solar system. It highlights the delicate balance and harmony that govern the movements of celestial bodies. The story of Pluto and Neptune's orbital resonance is a beautiful reminder of the wonders of our universe and the forces that shape it. Section 6: Pluto Up Close, Unveiling the Mysteries. Our understanding of Pluto was revolutionized in 2015 by NASA's New Horizons spacecraft. This mission marked a significant milestone in space exploration, as it was the first time humanity had sent a probe to the far reaches of our solar system to study Pluto up close. The journey of New Horizons, spanning over 9 years and covering more than 3 billion miles, culminated in a historic flyby that forever changed our perception of this distant dwarf planet. For the first time, we saw close-up images of this distant world. These images revealed intricate details of Pluto's surface, showcasing features that were previously unimaginable. The high-resolution photographs captured by New Horizons provided a window into a world that had been shrouded in mystery for decades. New Horizons revealed a surprisingly diverse landscape. From vast plains to rugged mountains, the variety of terrains on Pluto was astonishing. Scientists were particularly intrigued by the presence of smooth young surfaces that suggested recent geological activity, challenging the long-held belief that Pluto was a static, frozen world. Towering mountains of water ice rise above vast plains of nitrogen ice. These towering ice mountains, some reaching heights comparable to the Rockies on Earth, are composed primarily of water ice, which is as hard as rock at Pluto's frigid temperatures. The nitrogen ice plains, on the other hand, are smooth and reflective, creating a stark contrast with the rugged mountains. Craters tell the story of past impacts. The surface of Pluto is dotted with craters of various sizes, each one a testament to the collisions that have shaped the planet over billions of years. By studying these craters, scientists can learn about the history of our solar system and the processes that have influenced Pluto's evolution. Pluto's 5 moons, including the large Charon, add to its allure. Charon, the largest of Pluto's moons, is nearly half the size of Pluto itself and has a unique, rugged landscape. The other 4 moons, Styx, Nix, Kerberos, and Hydra, are much smaller but equally fascinating, each contributing to the complex gravitational dance that defines the Pluto system. The New Horizons mission provided a treasure trove of data. The spacecraft's instruments collected a wealth of information about Pluto's atmosphere, surface composition, and geological activity. This data has been invaluable in helping scientists piece together the story of Pluto's formation and evolution. Scientists are still analyzing this data today. The sheer volume of information sent back by New Horizons means that researchers will be studying Pluto for many years to come, uncovering new insights and deepening our understanding of this enigmatic world. Section 7, Conclusion: Pluto's Enduring Allure. Pluto, with its heart-shaped feature, its demotion from planetary status, and its intricate dance with Neptune, continues to captivate us. Though no longer considered a full-fledged planet, Pluto's story is far from over. It is a complex world with a rich history. Pluto reminds us that our solar system is full of surprises. As we continue to explore, we are sure to uncover even more secrets hidden in the distant reaches of our cosmic neighborhood. Watch my next video now!